I'm going to start out with, I don't know. Does anybody have an agenda of what I'm supposed to be saying? It's kind of a blur. Every weekend I'm somewhere else. And last weekend I was in Vancouver, and the weekend before that I was in San Francisco, and I kind of lose track of it. I think this is what I'm supposed to be talking on, right?
Yeah.
Okay. This is going to be 4 simple steps to healthier bees. So let me do a little preliminary here. Before you take a bunch of notes, if you go to here, or you just go to my website and look for presentations on the left-hand side of the bee page, the main bee page, there's a presentations one, and you can go there, and all these PowerPoints are out there. You don't have to write all of this down. So if you see a quote up there you really think is cool and you're trying to write it down, you can go look it up later. Assuming you actually have internet, I don't know. I assume they have internet here, right? Also, as far as books, I've got books for sale over here, but basically everything that's in my book is on my website for free. So you don't have to buy a book in order to read what I have to say. It's all on my website. I know that's not the best way to sell books, they tell me, but I seem to be selling a lot of books anyway, so I'm not going to worry about it. So that's where that stuff is. So let's talk about 4 simple steps to healthier bees. My first step is no treatments. I know that sounds backwards to everybody. Maybe not everybody. Let's talk about why. Here's one reason why. One reason why is the ecology of the hive. There's been an assumption over the years by the bee scientists that bees are just bees, that that's all that's in the colony, that there's nothing else in there. It's only really been since CCD hit that any of them had gotten really serious about trying to figure out how those things that are, other things that are living in the colony might affect their health. I shouldn't say all of them. Martha Gilliam back in the 80s was doing a lot of research on it, but nobody seemed to pay that much attention then. After CCD, and they couldn't find that smoking gun pathogen that was causing the problem, somebody finally started saying, well, maybe it's what's missing and not what's there. But the fact is that a hive is a very complicated ecology. I think the first time I did a cutout from a tree, I began to be aware of that when I saw all these things that were living in the detritus at the bottom of the hive, and all these things that were living in this bee colony that I could see. And that's not counting all the things you can't see. But just some things that are almost big enough to see, like mites. There's 170 different kinds of mites that live on bees. Of those 170 kinds of mites that live in a bee colony, there's 3 of them that are a problem. And 2 of those live in North America right now. So those other 167 may actually be beneficial if for no other reason than they fill a niche that maybe crowds out some of those other mites. We know for a fact a few of those mites actually eat varroa mites. But we don't know if they eat enough of them to be significant or not, but we do know that they eat some of them. I used to have 40 up there, and people kept questioning it, so I went and did some more research and found out that 170. I heard the 40 number from one of the bee scientists at one of the bee conferences, and so I wrote that down, but then I did some more research, and there's actually 170. And this is a link if you'd like to go look that up and see where it says that there's 170 of them. I can come up with 30 insects I've observed in a bee colony. I don't know how many there actually are, but that's just a pretty good guess on what lives in a bee colony. Some of those actually, one of them is a bee louse that will live on the bees. You can actually see them on the backs of the bees sometimes before everybody started treating for mites. I don't know that they were helpful, but anything that fills a niche in the ecosystem is often helpful just because of the niche it fills. Here's a link to a USDA publication that says that there's over 8,000 kinds of microorganisms that live in a bee colony. If you'd like to go look it up. And this is pretty much what, that link there is pretty much based on Martha Gilliam's research, and you can go read her research on Bee Unto Others if you want to go look at her research. They've scanned it all in and put it all online for you. It was all funded by the USDA, so it's all public, so you can actually, they can actually, it's not copyrighted, so they can actually publish it there. But she's the one who did the original research that they based that 8,000 number on. And that's really just what she could culture in a petri dish. There's probably 3 or 4 times that, because there's a lot of those microorganisms that just fill a niche where it lives off of the waste of this other microorganism, and you can't really culture it in a petri dish unless you culture the right thing that it lives off of. And microorganisms get really complicated in their structure of what fills what niche and how they're all related to each other, how they're all interrelated. So what are the effects of treating on that hive ecology? Well, fumidil, which seems to be popular in this country and illegal in most of the rest of the world, because it causes birth defects, it kills most bacteria and most fungus, which are probably two of the most beneficial classes of microorganisms in the colony. Terramycin is more targeted at the bacteria. The only good thing about terramycin I can say is that since it's been in use for 50 or 60 years, a new balance has been struck, kind of, because it's killed off all the bacteria that weren't resistant, and so resistant strains have developed that actually can survive the terramycin. When they started using tylosin in the last couple of years, none of those microorganisms had any resistance to tylosin, and they just wiped them out. But that's targeted at killing bacteria. Essential oils, they kill almost all kinds of microorganisms, from viruses, bacteria, yeasts, fungus. Organic acids are very useful to kill any kind of microorganism. If you ever worked in a lab and you're trying to sterilize things, formic acid is a great way to sterilize things because it pretty much kills everything. But just a shift in the pH in the colony changes what lives and what dies, even if you change it a little bit. When you change it drastically enough to kill the mites, you've changed it drastically enough to kill a whole lot of these microorganisms. Acaricides, I'm using this term mostly to refer to these insecticides that they've relabeled as acaricides because they put them in a bee colony, and I don't think they thought that the beekeepers would buy calling them insecticides and put them in a bee colony, but they're basically insecticides. Fluvalinate, Coumaphos, Amtraz, these are basically insecticides that have been labeled as acaricides, and they're using them to try to kill mites. And those will not only kill the mites, they'll kill all of the smaller insects that are in the colony. Because basically, you're trying to kill a bug, an arthropod. On an arthropod, you're trying to kill an arachnid that's on an insect, but they're not that different. They both have the same kind of structure. They even have some of the same kind. If you study their life cycle, you'd be surprised how much their life cycles have in common. A haploid varroa mite is a male, and a haploid bee is a drone, and a diploid varroa is a female, and a diploid bee is a worker. So this is part of the issue too, is what do you call beneficial and what do you call benign and what do you call a pathogen? The lines are pretty blurred if you pay any attention to any kind of ecology at all, or any kind of organism and the microorganisms that are living on and in that organism. Anytime you take a microorganism that's living on and in your body and put it in the wrong place, it becomes a pathogen. If you put it in the right place, it helps keep you healthy. You have bacteria that lives on your skin that if it wasn't there, you would have fungus living on your skin. And so it's actually displacing that fungus, but that staph that lives on your skin is not good when it gets in your bloodstream, and it's not good if it gets in a cut. So is it a pathogen or is it a beneficial organism? Well, it's a beneficial organism if it's in the right place and the right balance. So what we want is things that are in the right place and the right balance. Chalkroot spores actually prevent EFB. EFB seems to be making a comeback, but back in the 60s it sort of died out because of the chalkroot. The chalkroot came in the 60s, and EFB just sort of disappeared. You didn't hardly see it anymore. And now there seems to be some outbreaks. I'm not sure. The cause of that is probably the tylosin has upset the whole microbial ecology, is my guess, but I don't know. We know there's bacteria that crowd out EFB and AFB. There's some research on bacteria that live in the gut of the bee. This actually gets rather complicated. The first wave of research was really Martha Gilliam, who just noticed it was there and noticed that they seem to have less AFB. The next wave of research on it discovered that this bacteria actually makes a biofilm in their gut that coats the inside of their gut and protects them from things like nosema, because it makes basically a film that protects their gut. Well, the next wave of research seems to be showing that bacteria that's in their gut, when they're feeding the nurse bee seems to stimulate their immune system that causes them then to resist things like AFB. And without that bacteria in their gut, it doesn't stimulate their immune system, and then they're susceptible. So what happens is you treat with antibiotics like terramycin, you make them more susceptible to getting AFB, which is what you were trying to prevent. And if you treat them with Fumidil, you kill off that bacteria that's making that biofilm in their gut that was protecting them from nosema, and you make them more susceptible to nosema. So anyway, that's some of the natural flora that lives in the gut. The other thing about microorganisms in a bee colony, this is a very direct effect that's very easy to measure, is that bees really can't digest pollen. I know most of the bee books seem to indicate that young bees are raised on pollen. No, they're not actually. They're raised on bee bread. Bee bread is made from pollen, but to say that bee bread is pollen is like saying sauerkraut is cabbage. Well, sauerkraut's sort of cabbage, but it's not really cabbage. It's cabbage that's been fermented. It's not the same product when you get done. Bee bread is digestible because the bacteria and the yeast have broken down the coating that seals up that protein that's inside that pollen grain. And until that has fermented, they can't really digest it. In fact, this may be one of the smoking guns that may eventually come up as part of the problem with CCD, is that they're spraying a lot more fungicides than they used to. The fungicides are getting in the colonies and killing off all the yeast that are required to ferment the bee bread, and then the young are dying of malnutrition because they're not getting any nutrition because the pollen isn't fermenting. If you want to look up the lactic acid bacteria one I was talking about, if you look up symbionts as major modulators of insect health, I think there's 2 or 3 places that posted this online. It's available, the whole study is available online last I looked. And it's a very interesting study if you're interested in that kind of stuff. Back to the idea of a benign organism and a pathogenic organism. The other thing is that microorganisms tend to form, I don't know what you'd call it. A society is probably the best description of it. What do you call it when you have a colony of this here and a colony of this here? And these colonies are all interacting with each other to create an entire ecosystem of microorganisms. Even something that just fills a niche here may not be obviously pathogenic, and it may not be obviously beneficial, but it may be filling a niche that would have gotten filled with something that is a pathogen, or it may be filling a niche in such a way that it's feeding something that's preventing a pathogen. I mean, it can get so complex that this is part of the problem. Then this is part of the problem with science. Science likes to isolate this one little thing and say this one little thing does this one thing, and we can manipulate it in this one way and make this one outcome. But reality isn't that way. Reality is everything's connected to everything else. And the complexity of how everything is related to everything else is something we may spend lifetimes trying to unravel. Oops, went too far. My second reason for no treatments is to put the selective pressure where it belongs. I think I have heard almost all of the bee scientists I've spent any time or shared a podium with say at one time or another, if we'd have never treated for Varroa, we would already be past this. And I think that's true. We need to put the selective pressure where it belongs. As long as we keep cropping up bees that can't survive Varroa, then we just keep perpetuating the problem. I'm kind of baffled at the people who think they can breed bees that don't need treatments while they're treating, because it doesn't make any sense to me. I mean, that's like saying I can breed racehorses, but I never race them. Well, how do I know if they can race if I never race them? I don't know that. I've taken some criteria I think will make them good racehorses, and I've bred horses that have those traits, but I've never raced them. So I don't know. Well, I don't see how you can raise bees that don't require treatments when you're treating them. You don't know if they can survive without treatments because you don't really know all the complexities of what allows them to survive without treatments, and you probably never will, but it's easy enough to stop treating them, and the ones that can't survive die. It's not that complicated. So if you don't treat, you can breed for resistance to the problems your bees are facing. The other problem is, as long as you treat, you keep putting you keep putting selective pressure on whatever the pathogen is or whatever the parasite is in a way that makes them stronger, in a way that makes them able to reproduce more. In other words, the mites that are, the varroa mites that are going to survive when I keep treating are either the ones that are resistant to the treatment or they can outbreed the treatment. In other words, they reproduce fast enough that despite the fact that I keep killing them all off, there's still some left. And those are the ones that are going to survive, and I'm basically breeding a super parasite instead of a parasite that can live in harmony with its host. And what I need is a parasite that can live in harmony with its host, not one that can reproduce fast enough to keep up with all my treatments. So we're putting selective pressure in all the wrong places. And you're creating an artificial system. You're creating a system that, I could sidetrack on other issues because I think there's a lot of other issues in our society that are the same way, like modern medicine. But you have a body that has a system of checks and balances and feedback mechanisms, and when you start messing with that, the next thing you know, you've messed this thing up, so you have to try to fix this thing, and you mess this thing up, and now you have to try and fix this thing, and now you've created an artificial system that has all these outside forces extended on it all the time in order to keep it in this balance that it's in. And if you remove them, there's nothing to prop it all up anymore. And I don't think that's the kind of system we want. We need selective pressure on the bees and on their parasites that they can live in a system that isn't constantly being pushed at with other forces. So my third reason for no treatments is to keep the combs clean. The fact is, if you go, and I'll probably sidetrack a little more on this later, but the entire wax system is full of chemicals at this point, and they're chemicals that the beekeepers put in their hives. Amitraz, fluvalinate, humifos are all lipophilic. They like wax. They like oil. Wax is just a heavy oil. So they absorb into the wax and they build up, and they just keep building up. Now, there are things that will break them down, things like ultraviolet light, but there's not a lot of ultraviolet light in the hive. There's not a lot of ultraviolet light in the warehouses where they're storing blocks of wax that they're going to make into foundation. So the fact is, this wax just keeps getting more and more contaminated, and there's really nothing cleaning it up. So if you want to stop contaminating your wax, you've got to stop putting those chemicals in there that are contaminating your wax. That's a first step, and we'll talk about other steps. But the other problem with chemicals is they interfere with how the hive communicates. What goes on in the hive is a bunch of communication that's based on smell. The only other thing going on is the little dance language, but the little dance language is really just one piece of how they even find nectar. They come in and do this little dance that says it's that direction, it's that far, and it's a really good source. And that's what they communicated in the dance. But how do they actually find it? Well, they share some of that nectar with them and say, this is what it smells like. Because they got to fly out there, follow their nose, and find that. Yeah, the dance will get them going in roughly the right direction, and they have an idea how far they're going to have to go to get there, but they still got to smell it to find it. And that's being done by smell. But other things are being done by smell as well as that. There's all the feedback mechanisms in the colony, which are basically pheromone based, and most of those are smells. You've got pheromones that the open brood produce that stimulate them to gather more pollen to feed the open brood. You've got open brood pheromones that suppress the workers from growing ovaries. You've got pheromones from the queen that convince them that the queen is doing well and she's fertile and that they don't need to replace her. Or, if they're starting to fail, that the queen is failing and they do need to replace her. That's how they know the answer to the question of do we need to replace the queen, is by smell. Now you put a bunch of things in here like thymol, which will drive the bees clear out of the hive, and you think that's not going to affect the way the colony operates? Because that's how it operates. It all operates on smell. And some of those essential oils, like lemongrass oil, is almost a dead ringer for Nasanov pheromone, which is a pheromone they use to get organized. And so some of your essential oils are not only killing off microbials and not only just plain interfering with the ability to smell, but they're actually stimulating some of those pheromones. So what are the downsides of not treating? Well, this is the argument everybody will give you, is that some of your hives are going to die because you didn't treat them. Well, I hang out with a lot of beekeepers, and a lot of them are treating, and a lot of them are losing their hives. I don't really see a significant difference between the number of people who are treating and losing hives and the number of people who are not treating and losing hives, or in how many hives they're losing. I don't see a significant difference. But the theory is, if you stop treating, you're going to lose more colonies because there's that selective pressure going on for the varroa, that selective pressure for some of these other things. And so in the long run, it should get better. Actually, I'd say I'm probably losing less hives than most of the people I know who are treating, and I think that's where you should end up. You should end up losing less in the long run, even if you did lose more in the beginning, and I don't think you will. But even if you did, I think you're going to end up where you need to be if you lose a few more. I don't quite understand I'm beginning to get a grasp of this. I just read a book called Sway, the Irresistible Pull of Irrational Behavior. And one of the number one things that the guy points out about irrational behavior in humans is the fear of loss. We are so afraid of losing something, we will throw good money after bad any day of the week to try to keep from losing what we've already invested in it. It's how poker works, you know. The whole idea of hold'em and poker is to get enough money in the pot that your fear of loss will keep you in the game, rather than you'll go, I'm not going to win this, I may as well get out. No, you won't do that because of your fear of loss. Because people will hang on to a stock from a company that's crashing, and obviously the company's going to go under, and everybody's telling the person the company's going to go under, and they'll hang on to it hoping it won't. Or the person who panics because it went down just a little tiny bit, and it's nothing but a little dip because of some panic, because some little league team lost the game somewhere. You know, I don't know what causes the stock market to do this, but it does a little down, and they panic and they sell because they're afraid if it goes down more, they'll lose more. But that's just how they decided to view it. That's their view of it, is that I'm losing money if it's going down, rather than, oh, the company's stable, the company's making money, I should just not worry about it. But that's that fear of loss. It's that irrational fear of loss. I used to call it, and I think there's a little bit of something to this too, but maybe the two are related. There's this I've got to do something even if it's wrong idea that humans fall into. You know, this situation isn't what I want, so therefore I have to do something about this situation, even if it won't help. And I don't think that's a rational view of it, but it's how humans tend to think, and it's why doctors for millions of years have always done well. Because people want to do something even if it's wrong, and you can always do something if you don't care if it's right. Anyway, I think the rest of these, other than that some of your hives might die, the rest of these are all upsides. Pretty much, if they die, you're getting rid of the genes you don't want, and if they survive, you get the genes you do want. And meanwhile, you can just try and outproduce the problems you're having. If you do splits, get swarms. I know lots of people who are just doing swarms and cutouts, and they never buy bees, and they're selling bees to people because their bees are thriving, as they're starting with stock that can do well, and they keep doing splits on their own, and they keep catching swarms, and they keep doing cutouts, and they keep selling bees to other people. And they have a pretty self-sustaining system going, and they aren't treating at all. So what are the advantages of not treating? Well, you don't have to put the treatments in, you don't have to go out and take them out. There's so many different treatments around now, it's hard to say what all it might be, and whether you have to put it in and take it out, or how long you leave it in, or whatever. But it's obviously a lot of cost and a lot of effort. And if you don't treat, you're not going to contaminate your wax, you're not going to upset the ecosystem of the hive, and you're going to breed for bees that can survive and mites that can live in balance with the bees. So that was my first of my 4 simple steps, was no treatments. My second step of the 4 simple steps is breeding local survivors. Local survivors, by definition, are adapted to your climate, or they wouldn't be surviving. I don't know how many of you have bought packages lately, but the last time I bought packages, they were a disaster. I mean, I don't think I'll ever buy packages again. I was trying to do a quick build back up because I'd been out of the country, so I bought a few packages thinking I'd just raise some queens and requeen them, and I got busy speaking and never got that done, and they all boomed and did really well all summer, and then all of them died in the winter. Just none of them were cut out to survive in my climate. I need bees that are adapted to my climate, and bees that aren't all so inbred that they have no genetic diversity. The packages are coming from people who are taking one queen, taking her larva and grafting tens of thousands of full sisters. And that's just a genetic bottleneck. And that genetic bottleneck is catching up with us, I think. I think that's why the package quality keeps going down. The other thing is people keep wanting their queens earlier and earlier, and they want their packages earlier and earlier, and so they're trying to push them harder to get them going earlier, and they're trying to make queens when there aren't really enough drones out there to mate with, and they're trying to raise queens when there's really not enough food to get them well fed. And a well-fed queen is way better than a poorly fed queen, and a well-mated queen is way better than a poorly mated queen. And genetics is, it's helpful. I certainly try to pick good genetics, but frankly, you could take a mediocre queen and raise some really good queens off of her if you get those queens well-fed and well-bred. And that's not happening with the packages because they're doing them so early, which isn't entirely the fault of the people who are doing them. That's what people keep demanding, and so they try to meet that demand. But it's not working out well. You can raise better queens because you can raise them at an optimum time for nutrition and drones, and that's not that hard to judge. If you don't have drones flying, it's too early. If you do have drones flying, you go out there, you see a lot of drones flying, it's probably a good time to be raising queens. If you've been beekeeping very long, you've probably started figuring out when prime swarm season is by when everybody starts calling you for swarms, or by when your bees swarm. Right before that is probably the best time to be raising queens. Like 2 weeks before that is probably perfect. Right during that isn't a bad time to be raising queens. So you can raise queens at an optimum time so that they get well fed, and so there's plenty of drones out there for them to mate with. The guy who's trying to make a living raising queens, he's just got to try and kick out enough queens to put his kid through college and pay his mortgage. He's not trying to raise the best possible queens. He doesn't have time. For the price he's getting for them, I don't see how they can even afford to raise them. I'm sure they've got some cheap labor in order to accomplish that. The other thing is, I used to wonder about queens I'd get that you'd buy a queen and it'd take 2 weeks before she'd start laying. I always thought they were banked too long, so I did some experiments with banking queens, and it didn't seem to matter how long I banked them. They'd still start laying as soon as I put them in a colony. So looking at all the research, I came to the conclusion what they're doing is they're banking them too soon. You take a queen that just barely started to lay and you put her in a cage and you put her in a bank and her ovarioles get stunted. She doesn't develop. When her ovarioles start to develop and she first starts to lay, she needs to lay for about 3 weeks in order for them to get fully developed. Once they're fully developed, you can bank her and she'll do fine. But if they're not fully developed and you interrupt that development, then they never finish developing. And that's it. So you end up with a queen that doesn't have well-developed ovarioles. And a queen really can't lie to the bees about how fertile she is. She either is or she isn't, and her pheromones don't lie. Her pheromones tell them that she is or isn't. So you have all these queen supersedures these days, partly because these queen breeders don't have time to leave them in a mating nuke for 3 weeks when they could pull them out 2 weeks earlier and put another queen cell in there and get another queen and ship another 2 more queens out in that same amount of time. They don't have time to allow that to happen. You do. If you're a hobbyist, you've got the time to do that. You can let them lay from the time you put them in the mating nuke, or you could actually introduce the cell to the hive you wanted the queen in. And then she emerges and she just keeps right on laying, and you don't interrupt that ovarial development, and you get a queen who lays well, and a queen who has lots of good pheromones to keep the colony together. So you can raise better queens. That's my point. The other thing you can do is try not to remove the selective pressure that needs to be on the bees. For instance, in a wild colony, if a queen starts to fail, they have to sense it and replace her or they die. If the colony dies, the genes don't get passed on, and that's the end of that. That gets selected for. It gets selected for bees that can sense that the queen's failing and replace her before she fails, right? Now what happens if you buy queens every year that are raised by some queen breeder who just keeps raising queens off of whatever queen they happen to like, and then you requeen every year, and the bees never have to requeen themselves. We've removed all the selective pressure for bees that can sense that the queen's failing. And now you end up with bees that can't sense the queen's failing, and the whole colony fails before they figure it out because there's no selective pressure for that anymore. I prefer not to requeen every year, but if I see one that's failing, I'll go check it out and maybe I'll give them a queen. But usually when I see one that's dwindling and I go in and check, I find out they were already raising a new queen, and I don't really need to. They're already taking care of it. But we can breed for that. You can also breed for longer-lived queens. You can, especially if you market your queens, you can keep track of how old they are. If you got a queen that's still doing well in her 3rd year, maybe you want to breed from those queens and get queens that can do well for 3 or 4 years. And that used to be the norm. The norm used to be that a queen would usually get superseded in her 3rd year. That was pretty much considered the norm in beekeeping from the 1800s until at least the 1970s, 80s, 90s. Somewhere in there, it started getting to the point where it was more and more frequent that they would get superseded. And I was at a honey producers meeting in Kansas in 2004, and Nancy Ostergeis said she thought the average queen got superseded 3 times a year. And that's pretty sad. I don't know that that is or isn't true, and she wasn't stating it as an absolute fact, but that was her suspicion from the research she'd been doing, and she thought it was from the contamination in the comb. But the contamination in the comb leads to infertile drones and infertile queens who then get superseded all the time. So, what are the other advantages to raising your own queens? Well, obviously it's cheaper, but the other thing is if you have some spare queens around, you have something to work with. I think the idea that I'm going to have 1 hive is really not a good plan. 2 hives, at least I have some spare parts that I can borrow from this hive to get this hive going again if I think they might be queenless, or I think there's a problem. I can get some open brood from this one and put it in this one, and I've got a little more room to work. But Larry Connor is a big fan of the 2.5 hives, is what he calls it. Just basically you got 2 hives and a nuke. If you got 2 hives and a nuke, now I got a spare queen. If I don't view the nuke as a hive, I just view it as a place to keep spare parts. It's just a little colony that happens to have a queen in it in case I need a queen, and it's got some brood in it in case I need some brood. And I don't expect to overwinter it. It's just kind of there for spare parts. Now I've got something to get me through the year and maybe get me going into the winter. And maybe that I could even try overwintering that nuke, depending on how bad your winters are. And but I mean, Kirk Webster's doing it in Vermont. I think it could probably be done here. So you try and get these nukes through the winter. Now you've got that many more colonies come spring. Now some of you are in a backyard and you're thinking, well, I don't want, I can't have more than 2 hives. But you can always sell bees. You never have too many bees. Somebody's always wanting to buy them. You can always sell them. Trust me, that's not a problem. And you can always keep a nuke. You got your little stack of boxes here that's your hive, and you put a flat piece of plywood on the top, and you put another box up here that's your nuke, and put a lid on top of that. You would think anybody's going to know that's another hive? I don't think so. It's no problem having a couple of nukes. Now, it might be a problem trying to stack 3 booming hives on top of each other, but throwing a nuke on top of a hive, nobody's ever going to know the difference. But maybe the most important thing that's going to happen if you raise your own queens is by raising queens that are mating with those local ferals, and by keeping local stock that's surviving, you're going to contribute to the overall genetic diversity of honeybees in North America, and that may be important to the species, and even be important to the planet. This is an odd thing to come from Randy Oliver, who I think actually is trying to treat and raise bees that are resistant to mites at the same time, which I think is kind of a contradiction in terms, but I think he's right. If you're not part of the genetic solution of breeding mite-tolerant bees, then you're part of the problem, because if you keep propping up bees and keep raising bees that have no hope of surviving the mites, then you're just contributing, you're just keeping genes in the gene pool that are just weakening the whole species. You're not in an Africanized honeybee area, so you don't care about it. The third of my 4 steps here is natural food. This is actually some pollen. You can see how much different colors there are there. I'm not going to say a whole lot about pollen. I am a little baffled. It seems like all the people selling packages now are convincing all the newbies to go buy a pollen patty, and I don't quite understand that, because usually by the time I get packages where I am, there's pollen out there. And they're just going to ignore the patty because it's not even real pollen, it's soy flour, and there's real pollen out there. And so if you live in a small hive beetle area, pretty much it's just a smorgasbord for the small hive beetles, and they just love it. So if you want to raise small hive beetles, I highly recommend the pollen patties. If you want to raise bees, I'm not sure they're that helpful. Basically, though, pollen substitute just makes short-lived bees, and I don't really have any need for short-lived bees. Going into fall, I want long-lived bees that will make it through the spring. And in the spring, it never really helped me much in the spring. it may depend on your climate, but trying to incite them to raise more brood earlier than they normally want to where I am usually it just backfires. I either end up with, in a good year, I could end up with some booming hives that I get to split before the flow, because if I don't, they're going to swarm, which might be good if I wanted more bees, but that's in a good year. That's in a year where it all falls into place. In a bad year, I get a late hard freeze and I either get chilled brood and I get chalk brood out of it, or I get them stuck on brood and they can't move off of it and they starve to death. So it's usually not to my advantage to try to give them some pollen and get them raising brood any earlier than they would. My red maples are blooming before they can fly. And by the time it's a warm day they can fly, they can go get pollen from the red maples, and they probably shouldn't be raising brood before that. Otherwise, in my climate, they're going to get stuck in a cold snap and starve because they can't move off the brood. So I don't know. There may be some places where stimulating them to raise more brood earlier might actually get you a better honey crop. I don't know, but it doesn't work out where I am very well. And I don't really have much use for short-lived bees, so that's all I'll say about pollen. Let's talk a little about sugar syrup. I'm going to preface this a little bit because it's odd to me. I'll talk about this, and I tend to get people who come to two different conclusions about what I've just said. I get the ones who assume that I'm feeding all the time, even though I'm basically saying I don't. And then I get the ones who think that you should never, ever, under any circumstances, feed bees, which is not at all what I'm saying either. So if I think the bees are going to starve, I feed them. The last time I fed my bees was 6 years ago. So if that gives you an idea, I think you should manage them so you don't have to feed them. That should be your goal, is to manage them so that I don't have to feed them sugar syrup. I can leave them honey. But that doesn't always work out, because sometimes I get a drought all summer and a failed fall flow because the drought continues, and I got to feed them or they're going to starve. And I have no qualms about feeding them if they're going to starve. I feed them. If I can manage them though so that I leave them enough honey to get through the winter, that's my preference, because I think I end up with healthier bees that way. And oddly enough, it's a lot less work. I know that's hard for people to grasp sometimes, but let's just look at how sugar syrup messes with things like the microbial colonies that are living in the bees. Sugar syrup has a whole different pH from honey. Honey runs between about 3.2 and 4.5. Sugar syrup's about 6.0. Martha Gillam's research that I mentioned earlier on the microbes that live in the gut of the bee, she noticed shifts in the populations of the different microbes just based on different nectar sources. There'd be a different flower blooming, and this bacteria would thrive, and this one would kind of get set back just because of the differences in the pH.
Who was that?
Martha Gilliam. If you go to Be Unto Others, in fact, probably the simplest is do a Google search on site:beuntothers.com, and Martha Gilliam, it should take you right to all of her research. But just the shift in the pH from the different nectars would shift what bacteria were thriving and not thriving. But that's just that shift between that 3.2 and that 4.5, not dropping all the way down to 6.0. Now, oddly enough, if you go look up how to culture any of the bee brood diseases like EFB and AFB and chalk brood, you culture those at 6.0. They don't culture very well at anything else. If you want to try to culture AFB, you want 6.0. If you want to try and culture EFB, you want 6.0. So sugar syrup is the perfect environment for AFB and EFB and chalk brood to live. And 4.5 is not. So, and it's the same with Nosema. Nosema reproduces very well at 6.0. It does not reproduce very well at 4.5. So this is just one aspect of honey. There's other aspects of honey. Honey has a lot of, honey is 99% sugar, and that's a fact. And I think people get misled in both directions. Again, I find people arguing with me when I try and say, well, what they need to get through the winter is mostly sugar. That doesn't mean they wouldn't winter better on honey for several reasons, one of which is pH. But there's also some vitamins in there, in pretty small amounts. Not very big amounts, that's for sure. but there are some small amounts of vitamins in there, and there's certainly some trace minerals in there. Now, trace minerals are always in small amounts by definition, but trace minerals are essential to life. We can't live without them, and bees can't live without them either, and there's really no trace minerals in that sugar syrup, but there is in the honey. Now, are they in very big amounts? No, they're not in very big amounts, but are they important? Probably pretty important. I don't know. I don't know of a lot of research that's been done on it, but I'd say they're probably important. This is just a historic observation. I always find it interesting to find these old beekeepers who come to their own conclusions just on observation, not on necessarily research, but J. Smith used to live in Indiana. He raised queens there for years and years and years, and of course everybody wanted earlier and earlier queens, so finally he moved to Florida and started raising queens there. And he noticed that there was a lot more AFB in places where they fed a lot of sugar syrup, because when he went to Florida, he quit feeding sugar syrup because he didn't really need to. And that was just his observation. And now actually, two pieces of research I quoted earlier about the symbionts as major modulators of insect health, and then one that's been done since then on, I'll have to get it posted on this, because it just came out a month or two ago. There's one on that bacteria that's in that first study. Getting fed to the larvae stimulates their immune system to give them resistance to AFB. And sugar syrup disrupts that bacteria in their gut because it's a different pH. You can do a search on all these and it'll basically tell you where they do well. Here it says it's basically saying the lower pH value is equivalent to that found in honey, which is like 4.5 and on down. Drastically reduced enlargement in germ tube production, which is basically the reproduction of the chalk root. And you can basically you can go Google all of these on pH and how to raise them in a petri dish. I'll basically tell you that to culture them, you need it to be 6.0. So how does that affect the other 8,000 microorganisms that are in the colony? I'm sure it disrupts them. Anytime you change the pH, you change what lives and what doesn't, as far as microorganisms. So the argument against leaving honey for feed is the cost of the sugar. Everybody I've ever heard argue this just says honey sells for this much a pound, sugar sells for this much a pound. The difference between this is my profit that I've passed up. Well, if you figure your labor's not worth anything, and if you figure that you're not going to set off any robbing and you're not going to cause any other problems by feeding, then maybe that's true. But my experience is feeding in the fall, I tend to set off a lot of robbing. And feeding in the spring, I tend to bring a lot of ants. I tend to cause more problems feeding than I solve usually. Not that sometimes it isn't worth feeding, sometimes that's the best bet, but it never comes without a price. There's always a cost in labor, and there's a cost in the problems that you create that you have to deal with. So honey may be worth more than sugar, but if you consider that if I leave the honey, I didn't have to harvest it and then feed something back to them, that's a whole lot less work right there. Plus I got to make the syrup, plus I got to haul the syrup out there, and then I got to feed it, and then I got to deal with all the robbing I set off, and then I got to try and solve my ant problems because I brought all the ants with the syrup, because they're all attracted to the syrup. I got to deal with all those problems. To me, by the time I've dealt with all those problems, I don't think I came out very much ahead. Maybe, if they were all going to starve, I probably did, because I wouldn't have any hives in the spring. But if they weren't all going to starve, I may have just caused more problems than if I'd have just left them some honey and not harvested it. So the upsides of leaving honey is I get less robbing, less drowning. I don't care what feeding system you're using now that you think won't drown bees. Eventually it will, and you can take that as my prediction. Because I keep looking for a method that won't drown bees, and every time I think I found it, then the weather shifts and the can in my head up there drips, and something always happens. A lot less trips to the bee yard, less brood disease, and a healthier, more balanced ecosystem. So that's the upsides of leaving honey. Let's talk about natural comb. This is my fourth. I had no luck keeping bees alive without treatments when I had them on standard foundation, which is, I'll call it large cell from here on, because basically they enlarged it, and we'll talk a little about that, but I had no luck at all. Now, there's people arguing this one way or the other. There's been some research done that's on the positive side, some research done that's on the negative side. I don't care too much about any of that because I've been keeping bees on natural comb and not having any varroa problems for more than a decade, so they can argue all they want. I don't really care. But either it'll help with varroa or it won't. The fact is, if it does, then you've solved your varroa problem, and if it doesn't, then you haven't hurt your varroa problem. So we'll leave that at that for now. But the fact is the standard foundation has been upsized. And there's somebody out right now trying to argue that this isn't true. But this is just absurd to argue that this isn't true because I can come up with 100 old references that are measured. They'll try and make the argument that the whole... They used to have this rhomboid method of measuring cell size that was really complicated. And then they're arguing that the way that math was done and the way some other people are doing the math, that it was really something else. I don't really care. There's hundreds of references and old ones that are just measuring across cells. It's not complicated, it's a measurement. You know, there's no formula involved, you measure across the cells, that's how big they are. Usually you measure across multiple cells and then divide by the number of cells, but basically usually you're measuring across 10, dividing by 10, and you've got what it is for 1. But there's plenty of old references that's how they were measuring. It's a simple, straightforward measurement. There's plenty of old articles in bee magazines that you can still find on Cornell's Hive and the Honeybee collection where they've scanned all these old books and all these old magazines in that you can go look at where they're discussing this whole process of how they upsized the bees and whether that was a good idea or not at the time that they were doing it. It started in the late 1800s when Bedeau first did some research on enlarging them, and then he was a big proponent of it, and over the next few decades, several of the bee companies started making foundation that was enlarged, and several of the bee scientists, including Grout and Cheshire and a bunch of these other guys, had big discussions on the bee magazines on whether that was a good idea. And so to pretend that this never happened is kind of a mystery to me. It's like this is a historic thing that's easy to go find the historic documents and read them yourself. So go do that. then you don't have to argue about it. The most recent one that was done was McMullen and Brown, and that was partly why they did it, was everybody was arguing over whether or not they actually enlarged bees or not, and they said, well, what the heck, let's just find out. So they got an old mold of what was used in the 1800s, which is smaller, and they documented that it was. They got this old mold, and they made, those old molds are still around, you know, most people don't throw those things away. They cost the equivalent today of several $1,000s back then, so why would you throw it away? So they made some of the smaller foundation, some of the larger foundation, erased some bees, and measured all the bees to see if they were bigger, and they pretty much proved what everybody already said was that if you put them on bigger cells, you end up with bigger bees. But anyway, I've got a list of a bunch of those historic ones. If you go to here, Bee Natural Cells, kind of at the bottom of the page, I've got a bunch of references to those old books, and I'll link to that study right there. And you can look up a lot of those on, like I said, Cornell's Hive and the Honeybee collection has a lot of those old books. If you don't have them, I have them sitting on my shelf, and I just quoted the specific ones I had. But they are in almost every, a lot of those are in almost every ABC, XYZ of beekeeping from the early 1900s until the 1970s. So almost any of those you can go find it. It might not be on the same page that I quoted, but it'll be in there. So let's assume this. They've changed the size of the cell in order to make the bees bigger. Now, if you believe that's a great idea, then I suggest you just keep using large cell foundation and ignore the rest of this. I assume the bees know what a natural cell size should be, and I assume that's what they ought to be building. That's why they build it. So why don't I let them build it? If you go to natural comb, you can let them build whatever they want, and you don't have to argue about cell size anymore. Now, there's another complicated discussion on regression, that once you get them bigger, they don't necessarily build it as small as they would have if they weren't already bigger, because they measure things somewhat by their body size. But all in all, if you just quit using foundation, eventually you'll have natural-sized bees. So let's assume if we let them, they'll do it. So what's the disadvantage to doing natural comb? I'll talk a little more about how you do natural comb, but let's just talk about some of the whys you might not, why you might not want to, or why you might have to adjust the way you do things. Change is difficult. If you're a new beekeeper and you start out a natural comb, you'll never know the difference. If you're an experienced beekeeper and you've been handling combs like this all your life, and you get a natural comb that's brand new and soft and full of nectar, that you're going to go like this with the frame, and the comb's going to stay like this, and it's going to fall off. And I can hand that to a new beekeeper, and they'll do that once, and they'll never do it again. They will feel so horrible about it that they'll just never do it again. But I hand it to an experienced beekeeper who's been doing this for the last 40 years, and they have a terrible time adjusting. They'll break 4 or 5 or 6 of them off, and they're just furious. They don't ever want to see a natural comb again. So it is difficult to adjust your habits. When you're in the habit of handling combs one way, you have to change your mental process. When you pick up a comb and you're doing natural comb, it may not be attached to the whole frame, or if you're doing top bars, you don't even have a frame, but you pick it up and you've got a comb here. You have to keep it in line with gravity, at least until it's good, tough wax. The wax will get tougher as it gets older. It gets tougher when it has cocoons in it. You can tell that it's tougher by the color. Brand new wax is white, and it's soft like putty. The bees come back and coat it with something that they produce in their saliva that makes it yellow, and it makes it a lot tougher. It changes the entire consistency of the wax. So you've got wax that runs the whole spectrum from brand new white soft wax that isn't attached at all, that's very likely to break, especially on a hot day, to it's got no cocoons in it, but it's yellow, so it's fairly tough, and maybe it is or isn't attached. The more it's attached, the stronger it's going to be. The more it's yellow, the stronger it's going to be, and if it's got cocoons in it, it's going to be a whole lot stronger. So what you learn if you're going to keep natural comb is you pick up a frame and you look at it and you make a judgment. You say, it's old brood comb, it's attached on all 3 sides, I can do whatever I want. I can flip it any way I feel like, I can try and get it lined up in the sun to find those eggs in the bottom and not worry about the comb falling out. On the other hand, on a hot day and I pick it up and it's kind of shimmering like jello and it's all white soft wax and it's not attached all the way around, I probably should just close this hive up and walk away, because this probably isn't the best time to be messing with them. Because it's already a hot day and that's already kind of iffy, I probably should just leave them alone. But that's a thing you learn every time you look at a frame to make a judgment, instead of just picking it up and doing whatever you want. And it's not that hard, it just becomes a mental steps you go through. You pick up the comb, you look at it and go, well, that looks pretty fragile, let's just put it back. Oh, I can do whatever I want with this one. So it is more fragile at first, eventually you work that out. Now, the leveling, I mention it because it may be a big issue, especially if you're doing some kind of pollination or anything and you're moving hives around. You may care about the fact that you really need, if they're drawing new comb, you need it level, because when they're drawing comb, they make a plumb bob. They're hanging. Maybe nobody knows what a plumb bob is anymore. Now they get an app on their cell phone, right? But they're hanging, and so they're in line with gravity. So if the hive's leaning like this, it may start on this top bar and end on the bottom bar of the frame next to it, and that may not work out very well for you. The bees won't care. It'll work out just fine for them up until you start ripping everything out. But you need to get it level side to side. Front to back doesn't matter. I always get these people who are like, well, I like to tip mine forward so the water runs out. Well, by all means, don't worry about it. This way and this way is not a problem. It's this way and this way that's the problem, because the frames tend to be tight against each other, and so the frames end up like this if the hive's leaving them like this, and then the combs end up straight up and down. So you get it between 2 different frames. So if you're putting them on pallets and you're hauling them around to the apples, you might want to make sure that you don't have, that they're not drawing a lot of new comb and you've got the pallet sitting on a slope like this, To me, this is a lot less work. I'm baffled by the people who think it's more work. I don't even understand the concept. Anybody who's ever put in wax, put in wires, crimped the wires, embedded the wires, anybody who's ever done all that work can't possibly think that it's more work to do natural comb. I don't see how they could. And yet, some of those very people are the ones who are trying to tell me that. I don't see that it's much, I see it as a lot less work. Basically, I can go buy foundationless frames from Walter T. Kelly, put the frame together, put it in the hive, and I'm done. Other than maybe I need to level the hive, I really need to level the hive anyway. One of the things you'll notice, especially you get a lot of rain here, so you got this hive and it's leaning like this. You know what happens when it leans like this? There's more weight on this side now because it's leaning. which causes what? It causes this to sink in more, which causes it to lean more, which causes this to sink in more, which causes it to lean more. Pretty soon the thing falls over. So leveling highs is something you really ought to be doing now and then anyway. So I don't see that it's that big of a disadvantage. But so I think it's a lot less work. And then you get clean wax, and you can't really get clean wax from foundation. You buy foundation, it's already contaminated when you bought it. And then what? Well, if you start with natural comb, they're just building the comb from their own wax that they made. So it's not contaminated. And then I think you get a lot healthier bees because you get natural sized comb and you get clean wax. You know, the cosmetic industry basically won't buy wax from the United States. They only buy wax from Africa because nobody in Africa can afford to treat their bees, and as far as out in the bush. And then the people in the civilized people who have them in Langstroth hives all got together when the Varroa first showed up and determined that they weren't going to treat, and they didn't. As a group, they decided we're not going to treat, and this thing will go away, and it did. And so they don't treat in Africa. Actually, I probably should point out one other thing about treatments in general. You realize fumidil and terramycin and tylosin and Apistan and Coumaphos and Amitraz are all illegal in almost everywhere in the world. They're illegal in Australia, New Zealand, all of Europe except England. They're illegal in Sweden, Germany, France, Spain. All of these things are not only not recommended there, but if you do them, they will put you in jail. They're not recommended by the experts, and they're not recommended by the government, and if you do it, they'll put you in jail, just so you understand. Fumidil causes birth defects. It's not allowed to be used in people. They originally invented it with the intent of using it in people, and then they basically outlawed it for the use in people because it causes birth defects. So what are we going to do? We're going to put it in syrup, feed it to a beehive. That makes perfect sense. Yeah, it didn't work out so terrible when they were just feeding it in the fall because it's a fairly short-lived chemical, and by spring it's probably broken down. But now that we got Serrana, everybody's so paranoid about Serrana, they're feeding Fumidil all the time, all through the year. So I find that scary. But anyway, your other choice, I suppose, if you want clean wax, there's only one other way to get it, and that's that you collect your own wax from your own bees and you make your own foundation, which is what Dee Lusby and Kirk Webster do. And I've watched them do it, and it is a huge amount of work, and I don't know why anybody would want to work that hard when the bees are perfectly happy to build it without it. So we mentioned this earlier, but all those Amitraz, Coumaphos, fluvalinate have all been shown to make infertile queens and infertile drones, and that causes frequent supersedures. If it's damaging the queens and the drones, it's probably damaging the workers. The difference is they live such a short lifespan, it's hard to notice the difference, but if you shorten the life of a worker, even by a little tiny bit, you've made a huge difference in the overall profit of the colony. If you look at a colony as an economy, basically to cover their overhead, you've got to haul in enough nectar and pollen to feed the nurse bees who are feeding the larvae to raise another batch of bees, right? Plus you got to feed all the field workers who are flying back and forth doing the work. And so you're not really making any profit until you've covered all of this overhead of maintaining the hive, and then you're actually coming out with some extra that you can store for later. So if you take the life of a bee, they start out there being a nurse bee, so they aren't foraging, and then they work their way up finally, and now they're foraging, and now the first week or two that they're foraging, they're just covering the overhead of the colony. They're just bringing in enough to feed that brood and to help, feed all the foragers who are flying back and forth and feed all those drones that are out there trying to mate with a queen every day. So they're just covering the overhead. That last week is when they start making a profit. Well, if you shorten their life by a week, you just lost all your profit. You just covered your overhead. You didn't make any profit. I think this contaminated wax is probably shortening the lives of those workers just the same as it is the queens and the drones. It just isn't as obvious. So how do you get natural comb? Everybody always asks me my favorite way. Well, my favorite frame is whatever frame I have in my hand that didn't cost me anything. If I've already got it, that's my favorite frame. If I got to buy it, well, I might buy some, you can buy foundationless frames from Walter T. Kelly that already have a cone guide on the top bar, and maybe it'll save you some work. But if you already have wedge top frames, you can break the wedge out and turn it, the wedge is like this, and you turn it this way, it'll stick down. And oddly enough, it ends up right in the middle. You would think it wouldn't. It seems in my head, it always seemed like it wouldn't, but it does. Because you've got almost an 1/8 gap here, and it's a little over 1/8 of an inch, and you break it and you put it over here, it's really right in the middle. But it's true that this ledge is a little taller than this ledge, but it doesn't seem to matter. They build it pretty much in the middle of the frame. So if I have a wedge top frame, that's what I would do with it. If I have a groove top frame, I'd either take some scrap 1-bys and run them through the table saw and make some 1/8 wide strips and glue them in there, or get some paint sticks and glue them in there, or get some craft sticks. Jumbo craft sticks are what they call them. You can go buy it at Michael's. If you went to a medical supply store, I think they call it a tongue depressor. But it's a little bit wider than a popsicle stick, which is, that's about the width you want to come out to make a good guide. If you take a real popsicle stick, it doesn't quite stick out far enough to make a really good guide. It'll work, probably, but it won't work as well as one that sticks out a little more. There's a tendency, though, I'll say this, it's another human erring in the way we think. There's this thinking that if a little is good, a lot's better. That's not true. Almost anything in beekeeping, you're looking for the right amount. You're not looking for a lot's better. And bees are pretty adaptable, so the right amount could vary a bit, but don't get carried away with any concept and say, well, if this is good, then this is better, because it probably isn't. You want it sticking down a 1/2 inch or 3/4 is all right. Anything 1/4 is probably all right, but 1/2 inch is a nice goal. I wouldn't sweat it too much, but there's no point trying to make it 3 inches, you know, or something like that. I like wood myself because it's fairly permanent. Once I put a wood strip in there for a comb guide, a comb guide basically is the bees are going to festoon, and when they do, they tend to view that as the center of where they're going to festoon and where they're going to build the comb. That's what a comb guide is trying to accomplish, is to get them to build it in the middle of the frame, right? Well, if it's wood, and if this hive ends up queenless, and then the wax moths eat it all up, I can just scrape it down and put it back in. If it's wax, then I got to scrape the whole thing out, take it back to the house, and put some more wax strips in there. So wax strips work fine. It's just that they aren't as permanent, and I'm lazy. I want to do this job once. I don't want to have to come back and do it again. So I tend to prefer the wood. Anytime you've got a comb between 2 drawn combs, it tends to act as a comb guide. And anytime you've got a row of cells already on the top bar, it tends to act as a comb guide. So if you have an old comb and of wax, you know, drawn wax, not plastic, you can just cut it and leave the top row of cells. In fact, you can leave a row of cells all the way around, and it tends to act as a guide, and they'll build the comb in the middle of where those cells already are. If you put it between 2 drawn brood combs, they'll tend to draw this comb right in between them. And I say brood because brood is a fixed thickness. Brood is always about 1 inch thick. Honey could be 2 inches thick. It could be a 1/2 inch thick. It could be whatever, because the brood comb has to be the right depth for a larva to develop into a pupa and develop into an adult and then emerge. And that's a fairly fixed size. They can cheat a little bit, and they will cheat a little bit, but they have a pretty specific goal in mind, and they tend to make it very, very straight, very flat. If you put an empty comb between 2 drawn honeycombs in a super that aren't capped yet, they'll just fatten up the combs they have until they get out to the middle underneath this new frame you put in, and you won't be able to pull the frame out, because they'll just grow it out to that, because they don't care how thick honeycomb is. It's already started. They'd rather just keep making it fatter than to try to build a new comb in the middle. So I wouldn't just stick an empty one in the middle of a bunch of drawn comb in a super. That doesn't always work out. Now, if it's capped honey in a super, it might work. Put it between some capped honey, and you put this in the middle, they may draw a new comb here. Usually it'll work pretty well. Anytime anybody tells you the bees will always do anything, you probably know they're lying, right? But usually, if this is capped and this is capped, they'll draw this one in between pretty well. I've seen people take a plastic frame and foundation and cut the middle out of it. I generally tell people I think that's way too much work and I wouldn't do it. And then somebody at a meeting just I don't know, a week ago or 2 weeks ago, told me that they saw me mention that, and so they decided they were going to do it, and they were really angry at me for even mentioning it because it was so much work, and they wish they'd never tried it. I'm not really recommending it. I just know people who've done it who were happy with it, but I think it's too much work. Here's what a lot of my foundationless frames look like. I ordered these from Walter T. Kelly before they were offering any kind of foundationless frames. They seem to have standardized on an end bar that has a groove in it now, and I don't think I like that for foundationless. For foundation, it's nice because the foundation will slip in it and it keeps the foundation straight. But for foundationless, I got one more place for wax moths and small hive beetles to hide in. I don't think I really wanted that, but these I ordered. They've always offered, and I don't know what Walter T. Kelly's going to do in the future. They got bought out by another company. It seems like most of the same people are still working there, because all the people I correspond with at Walter T. Kelly still seem to be the same people. I don't know what direction the company's going to take. I can't say. But anyway, last time I did business with them and bought these, they were still making the solid bottom bars, because they used to make, I don't know if they still have it or not, but they used to make a thin top bar with a slit in it. So you could it was a slotted top bar, so you could drop a sheet of foundation in there for comb honey. You just drop it in the slot, and it would rest on the bottom, and you'd put a box of those on, and on a strong flow, they'll build it before it gets time to buckle, and you get this nice comb honey without a lot of work to put all the foundations in. But so they always made the solid bottoms. So I just ordered solid bottoms and medium ends. And I asked them if I could custom order top bars with no grooves in them. So they made me 1,000 of them. They wouldn't cut the bevel on it for me, but they made me 1,000 of them with no grooves in them, and then I just cut the bevel on a table saw. So this is actually bevel. There's a V right here. You can't see it very well, but there's a V right there. So it comes to a point. And then the V's tend to build it down from the point. Now that's probably my favorite, because it tends to be reasonably strong. The bevel seems to be able to take a little more of this than some other designs, but they all work all right. So I made about 1,000 of those, and then I got somebody who made me 1,000 of them with the narrow end bars, because I'd really rather have this 1 1/4 than 1 3/8, because of the natural spacing of a brood nest is about 1 1/4. When they enlarged the bees, they went to 1 3/8. But I can fit 11 in a 10 frame box or 9 in a 9 frame box that way. So I had a guy make me 1,000 of those once, and since then I haven't really run out of frames. I've been busy using what I have. But this is a foundationless frame that's been drawn. Maybe you can see the bevel a little bit here. You can see it's kind of attached on the bottom, and it's attached a little on the side, and I took this picture just before I extracted it, which always seems to be one of the questions that comes up. Here's the typical questions are, can I wire them? Yeah, in my experience though, the wires are always in my way. I'll have a bunch of nice queen cells, I'm going to cut the queen cells out and there's a wire running right through the queen cell. Or I get that nice soft white wax. I don't know how many of you have ever had comb honey, but really good comb honey should be white and it should just melt in your mouth. And the reason it's white is they build it in a big hurry on a strong flow and they haven't had time to come back and reinforce it all yet. And that's when you want to catch it. Well, if I have no wires in it and I pull one out that's all nice and soft and white and it's not going to extract very well, it's perfect comb honey, so I just cut it all up for comb honey. But if there's wires in it, it's a pain. Yeah?
I was going to ask you, when you're going natural for your honey supers, do you have any problem extracting where maybe some of the wax comes out of there?
I extract them all the time. I don't have any more problems than I do with wired wax. I can blow out wired wax, just lights off, crank it up, it'll blow out. But I extract foundationless all the time. I don't have any significant problems. I do sort it though. I look at it. If it's nice and white and soft, I cut it for comb honey and I don't try to extract it. I just keep throwing all those back in one box, you know, while I extract the rest of them. And then if I've got a bunch of those at the end, I cut them all up for cut comb. So.
But you use a radial extractor, don't you?
I do, yeah.
And the tangential, that doesn't do well with the...
I don't know. I know people who are doing it in tangentials and they think it works better because you've got a basket to support it. But I don't know. I don't have a tangential. I can't say from personal experience, but I know people who do it all the time, and they seem to think it works better because the basket will support the comb and it can't blow out. So, I don't know. Won't they just build drones? Well, if you stick an empty frame in the middle of a brood nest that doesn't have a lot of drone comb, in the middle of the time of year when they want drones, they'll draw the whole comb drones. Because it's an itch they've been wanting to scratch for a while, and you finally gave them the opportunity. And now if you take this one out and you go, oh my gosh, it's all drones, and you remove it and you put another one in, they're going to draw it all drones too. And they'll keep doing that as long as you keep removing it. And if you finally leave a couple of them in there, they'll quit doing that. But until you leave a couple of them in there, they'll keep doing that. Because they have a threshold they have two thresholds they're trying to meet, and both of those thresholds vary depending on the state of the colony and the time of the year. They have a threshold that they want a certain amount of drone comb around in case they want to raise some drones, and they want a certain amount of drones around in case they need to mate a queen. So they have a threshold they're looking for both of those, but that threshold shifts throughout the year and based on the strength of the colony. A brand new package is not interested in building any drone combs. They have other fish to fry. So they're busy trying to build worker cells and raise workers. But once they get a certain critical mass, they go, oh, well, I think it's time we get some drones raised. And they'll start raising some drones. And then that shifts during the time of year, not just the state of the hive, like starting with a swarm or a colony, but also what time of year it is. In prime swarm season, they want to raise a lot of drones. In the middle of summer in the dirt, they don't want to raise any drones. And in the fall, they want to kick them all out. So that number of drones they'll tolerate shifts depending on the resources that are coming in as far as nectar and whatever, and as far as what time of year it is. So that there's a change over the course of the year. I think that's a hard thing for new beekeepers to get. You read bee books and they don't tend to talk about that so much as they just talk like a hive is a static thing, or it's just going to be constantly growing. But there's a yearly cycle that's going on here, and it has peaks and valleys in it that depend on other outside forces, like is it raining and are things blooming, and do we have a frost, and what time of year it is, and how long the days are, and all of that creates a yearly cycle that adjusts somewhat for specific circumstances for that year. So, yeah, they'll build a lot of drones right off the bat. One thing, everybody's concerned they'll mess them up more doing foundationless. The only thing that you get more of in foundationless is if they mess one up, they're going to mess up everything in the box. Because, let me assure you, bees build parallel combs. So if you have a top bar hive that you just put your bees in and they built this angled comb across there and you're hoping they'll figure it out, they figured it out. They're perfectly happy with it just the way it is, and they're going to build parallel combs like bees always do, and every single comb is going to be running that same angle across your box. And if that's not what you want, then you need to take steps to correct it, because it's going to keep going that way. They figured it out millions of years ago. They do whatever the heck they want, but they do build parallel combs. Now, they aren't perfectly parallel. They'll put a little curve on the ends sometimes, and they'll fatten them up a little where they put some honey, and eventually you'll see some kind of wiggly combs in there sometimes, but they build them parallel to each other, basically. So if you want the next comb to be in a particular place, then put a comb parallel to where you want the next comb to be, and you may end up with one next to it where you want it. But if you don't fix that, it won't get right. So do I end up, I don't think I have any more messed up comb doing foundationless than I do not doing foundationless. But it's usually either an entire messed up box or it's not. It's either all fine or the whole box is messed up. But I've seen plenty of foundation buckle and collapse and end up with combs going every which way, and plastic that was ignored, and they built fins going out this way, or they built this funny looking comb out from the surface and over this way because they didn't want to build on the plastic. I've seen all kinds of messed up comb on foundation. I don't think I've seen any more messed up comb on foundationless than on foundation. I think it's about the same. I think it's a wash. But you need to keep in mind they build parallel combs. So one good comb leads to another, and one bad comb leads to another. And at least with a Langstroth, you get a clean start in every box. We're in a top bar hive. Pretty much it's going to continue that way to the end. You need to get it straightened out. You might need to build some frames and get one of those tied in a frame so it's straight. But that's true in a Langstroth. If you've got frames, if you've got one that went crossways, maybe they built the whole box crossways. If you flip the whole box upside down and lift the box off of the frames, you can now see it from the end, and you can cut that first comb out and rubber band it in the frame, and you can just keep cutting it out as you go and keep pulling off frames as you go until you get to the other end and rubber band them all into some frames and put them back in the colony. Now basically, honey, I just harvested. It's too big a mess trying to rubber band it into frames, but you can put all the brood back in. And actually, if it's getting toward winter and it's a nice, cocooned, tough comb full of honey, you might even get away with putting it in a frame and rubber banding it in, but otherwise they're usually too fragile. So how fast can you convert over from treating to not treating, and from artificial comb to natural comb and whatever? Well, I try to go with the flow. I guess that's kind of my view of life in general anymore. When I was young, I was always trying to swim upstream, and it just never seemed to work out that well. I probably do go against the mainstream flow, perhaps, but as far as working with the bees, I'm trying to go with the flow of what the bees are trying to do. They're building up a lot of brood in the spring, and they've got resources coming in. That's a good time I can convert a lot of things, and they have resources to recover from it. I don't like to take brood away from them because they have too much invested in brood, but harvesting honey is what beekeepers do, so I don't mind stealing some honey from them as long as there's plenty more coming in after this. You know, and this time of year I wouldn't want to be stealing any honey from them. It's getting too close to winter. But in the middle of summer, early in the spring, yeah, I could steal all the honey they got, and they'll just get some more. Well, maybe not here. It might rain for 2 weeks. Then you might better leave them enough to get them through the next 2 weeks. I don't know. Where I am, I could probably steal all of it and be fine because it won't be raining for 2 weeks. It might be raining for a day, but it won't be raining for 2 weeks. If you take what some people are rotating out their comb, I'm not, but some people are rotating out their comb and they're doing 20% every year. Well, in 5 years, if you did that and you went to natural comb as you did that, in 5 years you'd have them all in natural comb. I think you could aggressively do this in a year or two if you really focused on it and you didn't just kind of, you could do it instantly like E. Lusby. She just shook them all off, threw away all the comb, and put them on foundation. And if you knew Dee, you'd understand that, because that's kind of the way she is. When she's going to do something, she just does it. There's no ifs, no ands, no buts, and no piddling around. She's going to do it. So she just shook them all off, threw away all the comb, and she did that 3 times. She did it once to get them on 5.1, and once to get them on 5.0, and once to get them on 4.9. So. And this is a dilemma. What do you do with all that foundation you've stocked up that's the wrong size? I don't know. I ended up finally throwing mine away because I was moving and I never did give it to anybody. But probably find somebody who's going to buy it anyway and sell it to them. I kind of hate throwing it in the landfill when somebody's making it in a factory somewhere. But if it's wax, it's easy enough. You can just roll it up and make candles. Just take the wax and roll it. Well, if it's got wires in it, maybe it won't work so well. I don't know. So assuming cell size really doesn't matter, I think you're still going to have bees on cells that they think are natural size cells. That's going to be a lot less work. And you're not going to have contaminated wax. And assuming that cell size does matter, then you get, you not only get the clean wax and the healthier bees and the less work, but you also solve your varroa problems. Those are varroa, by the way, in case you've never seen a varroa on a bee. This is on its back, still running around. These are under the turgets here. They're actually sucking hemolymph, aka bee blood, I guess. There's one under that turget. These are, that one's on its back. They look pretty immobile until you see one run. Man, they're fast when they run. They pretty much don't, they're a lot like the squirrel. You know how the squirrel is. Run a little, stop, run a little, stop. Well, they're kind of like that, except they stop a lot more often than they run, but boy, when they run, they're fast. I've seen them just, you know, this bee will start doing a get it off me dance. This other bee will come over and start trying to help it, and it's looking around in there, and all of a sudden that mite will jump off of this bee onto the other bee, and the first bee just wanders off like, oh boy, that's a relief. And the first one now is doing the get it off me dance, and nobody's helping him or her. It's interesting to watch. I've actually seen one running across a comb before. That was a strange sight. You know, just running across the comb. Wow, they're fast. They got little legs like, I mean, microscopic legs. But they get around. 4 simple steps. That's my 4 simple steps. Any questions? Yeah.
When you were talking about the pH level being different in the sugar water, I was wondering, I have read some places where it's recommended that you put a little apple cider vinegar in your sugar water to change the pH level.
My problem when I used apple cider vinegar was it set off a robbing frenzy, and anything with smell in it I don't want to put in syrup. If I put anything in syrup that has smell in it, it just tends to make more robbing problems. So I would use ascorbic acid. It doesn't seem to have any smell to it. You can go buy 1,000 milligram vitamin C tablets at like Sam's Club and a big thing like this. If you're going to adjust the pH, you're going to have to get some way to measure the pH for your water, because nobody can give you a formula of what's going to work for your water to get the pH in any particular thing. I would set the goal at 4.5. The reason I would do that is there's some research back when they were doing high fructose corn syrup at first, where a lot of bees were dying because it was too acidic, and it was up around 3.5, I think, and there were problems with it shortening the lives of the bees. So I'd be headed to the alkali end of what honey would be, which is a little bit acidic, about 4.5. That would be my target. In my water at my old house, which is the last time I was making syrup and trying to measure pH, that was 6 grams of ascorbic acid in 5 gallons of 5-to-3 syrup. And you have to dissolve it in the water before you put the sugar in, or it won't dissolve. So you put it in the water, boil the water, get the ascorbic acid all dissolved, and then add the sugar. But you have to figure out what it is in your water's funny stuff. If I take 5 gallons of water at my new house and I check the pH as soon as I put it in the bucket, it's about 7. And if I wait about 20-30 minutes, it'll be 6. And if I add any kind of acid to it, it tends to stay around 6 unless I add quite a bit, because it's got enough lime in the water that it acts as a buffer, and it's soaked up a lot of that. And I don't know what it is that's reacting with the air, but when the oxygen gets in there, it shifts the pH a lot. So, I don't know, water's funny stuff. You pretty much have to have a pH tester to know what the pH ended up. Does that make sense?
What about well water?
That's what I've got, is well water. We got a lot of limestone, I think.
So in terms of bee fondant for winter feeding?
I'm too lazy to make fondant. I just feed dry sugar if I'm going to feed them.
So then you wouldn't be
dry.
doing any adjustment in that?
No, I don't adjust it. I just put a sheet of newspaper on the top and dump the sugar on it. I suppose that would be the one advantage to doing fondant, is I could adjust it. I'm too lazy for that, so it probably didn't happen. But I'm trying not to feed them. If I have to feed them, I just feed them. But dry sugar is simple. I just put a newspaper on the top, dump an empty box on top of that, dump the sugar on top of the newspaper. If I lived here, I'd cut the newspaper off the outside. Where I live, I just leave it hanging there. But it rains too much here. You probably have to cut the newspaper off, or it'll lick too much water in. But that's simple, straightforward, almost no work.
So I don't think this is true, but someone had said to me, if you're doing the natural combs, it takes the bees longer than to get established.
It's not true at all, actually. Oh, I'm sorry, we were going to do Mike.
Yeah, well, Gail has a very outdoor voice, but it's softer in the back.
She's saying some people say it takes longer for them to draw a natural comb than to draw it from foundation. This whole thing's based on the theory that you can take a biological function and reduce it down to a mathematical equation. And the mathematical equation that they think they've reduced it down to is that it takes X number of pounds of sugar to make X number of pounds of wax, and therefore, because I gave them wax and they don't have to make the wax, therefore they'll be more efficient in making a comb. But that's irrelevant to everything, actually. But first of all, young bees make wax whether they're building comb or not. So they're already going to make the wax. It's just going to fall on the floor if they don't make comb out of it. So they are going to make wax. And so the cost of making the wax is irrelevant anyway. And it's irrelevant anyway, because what makes the difference in them making a crop is having a place to put the crop when it comes in. If they don't have any drawn comb, then they don't have any place to put it. And so they need to draw someplace to put it. And they draw a natural comb much faster than they draw on foundation, because I think they look at the foundation and they go, I don't know what to do with this. This isn't what I would have drawn. I don't know. Are we supposed to finish this or fix it? Or, I think it looks like broken comb to them. it doesn't look like we need to draw some comb. It looks like somebody started something here and then they tore it down, and I don't know what they did. I don't know which way are we going to go with this? Are we going to tear it down, or are we going to build it up? Or, you know, it's not the size cell we wanted, and so I think they hesitate. You can try this experiment any day of the week. Take a brood nest and pull a frame out here and put a frame of foundation in, and pull a frame out here and put an empty frame in, and see which one they build faster. And I guarantee you they'll build the foundationless one faster than the foundation. Because it's just the way they naturally draw comb. They festoon and they draw comb. Foundation is not how they naturally draw comb. It interferes with the whole communication. If you read Huber's stuff on all the details of how they're building this comb, they're communicating back and forth here all the time while they're building this comb, you know? And there's no communication. I have this wall of wax in the way. So it's kind of like it's kind of like a construction crew that has a system for how they build a house, and all of a sudden you imposed a whole bunch of rules on them that interfere with their entire method of how to do it. And now they've got to figure out what to do. And bees are smart, and they figure out what to do, but it's not as efficient as if you just let them do it. It just gets in the way. Yeah. Next.
And don't you find too, when they build their own comb, that they leave communication walls between?
Yes,
like,
they do.
They leave travel holes, they leave, yeah.
They especially leave them in the corners, and sometimes they leave them even in the middle, but especially in the corners, yeah. And those probably pay off in lots of ways, especially in winter, when you've got a cluster, and the cluster's on this side of this comb. This is like a wall in the middle of the cluster, and the cluster contracts. They have to get over on the other side of this comb. And if there's any holes here, that facilitates them getting over there. And if there are no holes, then they have to go over the top, or they'll go over the bottom, or go around the ends,
Where it's
which means
cold.
they have where it's cold. Yeah, exactly. All these are in the front row. Surely there's somebody in the back that has a question, right? I feel like I'm ignoring all the people back there. Any questions? Oh, well, we'll be back there.
Wait.
I found this summer that I can make
She's got a mic. Hang on just a second.
Thank you.
I realized this summer I can make twice as much money just selling chunks of honeycomb because people are so wacky for honeycomb these days.
Cool.
Is there an easy way to cut it up and harvest it without it leaking all over and losing so much? I mean, when you harvest the honeycomb, how do you usually do it?
Well, I've got like a cafeteria tray on the very bottom, and on top of that I've got, I don't know where they came from. I think they're cooling racks from baking. I don't know where they came from. I got them from another beekeeper a long time ago, but I think that's what it is. And it kind of stands up off of it, but a queen excluder would work to get it up off of the honey so that the honey can run off of it and it's not sitting in a puddle, you know what I mean? So I've got these cooling racks that are, you know, like a little bit ways up off of that tray, and I cut them up, put them on it. I cut them with a sharp knife. I bought these, you know, cutters, but they crush it. They don't really seem to cut. But they work pretty well for marking it. If I didn't already have one, maybe I would have just taken a piece of plexiglass or something and cut a template. But since I already had the cutter, I use it to just mark it. I just kind of, you know, give it a little push to kind of make a mark on the surface of the comb where I can see where to cut it. And a good sharp knife does more good than anything. A good sharp paring knife and just cut the comb. And then it drains down into the pan. And yes, it's messy. You want to make it not messy? I got a plan for an idea of how to make comb honey inexpensively without having to buy like basswood sections or anything. But I keep meaning to try, but I've been meaning to try it for about 7 years now. I just haven't had time. But I got what I think is a brilliant way to get it, just draw it basically on a little comb guide, and I can just take the comb guide off and not cut anything and sell it like that. But I haven't ever got that one done. But so I usually end up doing cut comb. You can do Ross rounds, but the problem with all those cassette kind of things is you've got to crowd them up in there to get them to even want to build it, and you got to have a really strong flow. It's difficult to get them to build in there, but the advantage is you don't have to cut them. You just put, you put the lid on and sell them, which is nice. If you want, I've got the comb honey. What is the name of that comb honey book right there? Is that the comb honey?
Honey in the Comb?
Honey in the Comb. Honey in the Comb by Carl Killian. It's a really good book on how to get them to draw the comb, but he's doing it in basswood sections. And if you don't ever want to cut them, that's one way to do it. I think Kelly's still selling those. I don't know. Kelly's changing right now, but Basswood sections is one way to never have to cut it. If you get them, build them in the basswood sections, then you're done. You just take the sections out, scrape them off so they're nice and pretty and clean, and sell them. But other than that, but you need a rack. You gotta cut them up and put them on the rack so they can drain. That makes sense. Next, I got one over here.
Well, I have an outdoor voice too, but okay. It seems, and I'm a new beekeeper, so put that down as I don't know much. The bees, the packaged bees that we get here come from California in April, presumably after some kind of harvest that they do down there. Is a bee in the sense of, and you want to change from foundations to natural foundation. Are the bees going to figure that out right out of the package, literally, or since this was the first year for them, and I gave them all foundations because that's all I knew, could I try this next year and give them no foundations, and they would figure it out? Because partly because they're from out of town, like way out of town, partly because these bees are now acclimated to my climate, which is mostly rain. So my question is the bee a bee? Can they figure this out in a reasonable amount of time?
It has more to do with what foundation they were on what foundation they're on now. It's probably a bigger issue now. But if I got a package of bees today and put them on natural comb, it's hard to say what they'll make because a lot of it depends on what they were on. I think a lot of them were on Pureco because I've had packaged bees that would build 4.7 millimeter, which is considerably, it's actually a bit smaller than small cell in the core of the brood nest. But natural cell tends to vary in size, so it's hard to say exactly what size it is when this is 4.7 and this is 5.0 and this is 5.1 and this is 5.2 millimeters diameter cell. But I think you're asking two questions, so let's try them both. First of all, is a bee a bee? Well, a package of bees, if I can give them a local queen, it's probably just bees. I mean, they may, how long lived they are may have to do with how much they were treated before I got them, and it may have to do with the microbial colony that's living in the bees, which may have an effect on their health. So a package of bees from somebody who's been treating them all the time may not do as well as a package of bees from somebody who hasn't been. But odds are it's got a good chance of surviving, especially if I get a local queen in there before winter. And by before winter, I really mean in enough time before winter for them to raise a whole batch of bees going into winter. Because my experience is the package bees just don't seem to winter. And I think getting a local queen in there makes a lot of difference in getting them to winter. As far as cell size, they tend to build cells based on their body size, and the foundation that's out there actually varies in size. If somebody buys what Man Lake is calling their standard plastic frame, it's actually 4.9 millimeters. That's what their standard frame is. That's unusual, but if you buy their premium frame, it's 5.4 millimeters. That's considerably larger. If you buy a Pureco medium, it's about 5.3 millimeters. If you buy a Pureco deep, it's about 5.2 millimeters. And so even within the same company, within the same product line, it varies. So based on what they were on, that has a lot to do with it. And there may be some genetic issues, but I don't think the genetic issues are as dramatic as just what they were raised on issues. So if you put them on 5.4 and you're going to try to regress them, my guess is what they'll build will be about 5.2. Might build 5.1. They probably won't build anything smaller than that on the first try from 5.4. But if they were on Pureco, which is like 5.2, they might build 4.9 to 4.7 on the first try. It's hard to say. In the end, as Winnie the Pooh said, you can never tell with bees. You know, but there's some truth to that. They'll end up doing whatever they want in the end. But if you started with a large bee, and the large bee isn't going to immediately and instantly build a smaller cell. I always ask the question, do you know what a cubit is? A cubit is the distance from your elbow to the tip of your finger. Well, my cubit may not be the same as your cubit. And I think that's how they're building cells. I think they're judging it partly by their instinct of the right size, but partly by measuring it with their own body. So I think a larger bee doesn't tend to go as small as a smaller bee. So in other words, if I took bees on a 5.4 and I let them build what they want, they'll probably build 5.2. If I take those bees and let them build what they want, they'll probably build about 4.9. So in 2 turnovers of comb, I might get there. Then again, those bees genetically might not be so predisposed to get that small that fast, and it may go from 5.4 to 5.2, and then from 5.2 to 5.0, and then from 5.0 to 4.9. So it may take me 3 turnovers of comb to get them there. And it's really the turnovers of comb more than the bees, because once they build this comb, they just keep reusing it, and that keeps making bees that size who keep building comb based on their body size, and so, you know, it's really turnovers of comb more than bees. If I take a bunch of 5.4 bees and put them on 4.9 drawn comb, I'm done. They're small. The very next generation that comes out of those will be small bees. And they'll just continue to use the comb they have. Does that make sense?
Question?
30% of it, yes, thank you.
Okay, I'll ask the question for the people that have been doing it a bit and want to change. So I got boxes full of originally wax foundation with wire. Okay, and I've extracted, and so I got all this piled up. And I like the not doing too much work part. So if I cut and leave a stubby all the way around, pull the wire out, does that save me doing this woodwork?
Sure. Yes.
Good. Less work. I love it.
You may need to get some practice in figuring out how to get the wires out without ripping the comb all to pieces, but yeah, it'll work.
Well, I want to take all out in the middle.
Right. I'm just saying though, the wires are kind of in your way, and it's easy to rip the comb all up if you're not careful about how you get the wires out, but I think you can get the hang of getting the wires out without tearing it up. But you may tear up 1 or 2 before you figure that out, is what I'm saying.
But I'll end up with foundationless frames that'll work.
Okay.
That's my goal.
All right.
First of all, I'd like to thank you for reinforcing what I've been teaching for about 7 years. To me, it's just amazing that where I ever got these concepts about not treating, about don't feed, and all those things a long time ago. I don't know if you remember Roy Thurber. Do you know who Roy Thurber was? He is the Thurber Memorial Chair that hired Steve Shepard at WSU, Washington State University. It was his, after he died, his wife and his daughter put together that money to fund Steve Shepard's chair at WSU. That's who that was. Okay, my question is, all of this that we've been talking about, small cell size and its consequence, how dramatic is it that change that will come about doing that? The reason I ask is I have not been doing any treatments or anything for almost 7 years with my bees, maybe 8 years, and I do use standard foundation, but I see very, very small amounts of mites being reproduced in my combs all of these years.
Well, for one thing, you've been selecting for bees who can survive with mites, and that's a step in the right direction. And mites that'll live in harmony with the bees, and that's a step in the right direction. And, I don't know. I never could keep them alive on large cell foundation. They just all died, and I wasn't treating. I was doing pretty much what I'd been doing for decades before that, and pretty much what I'm doing now, which is not treating. But they were all dying from varroa until I got on natural cell size and or small cell size. To me, it just makes sense, though, to let them build the size they want. How dramatic is the difference? Well, if you look at volume, Badeau measured the volume of the smaller cells and the larger cells, because not only are they smaller in diameter, they're also smaller in length. Because when they make them smaller in diameter, they make them smaller in length because they're proportional. So what you end up with is basically you have a bee that is half again the volume of a small cell, a natural cell bee. A natural cell bee is basically 3/4 of the size of a, well, I don't know how to do the math the other way around. Basically, it's 150% bigger. It's 150% of the size of a natural size bee. People who, my son, who pays no attention to bees and pays no attention to anything I ever say about bees, goes and sees the bees at the state fair that are in this observation hive. I've got an observation hive in my living room, so he sees them every day, whether he wants to or not. And so he looks at these bees in the observation hive, he goes, "What are those?" I said, "Those are honeybees. They're huge. Why are they so big?" I said, "Well, they're on artificial comb." He says, "Well, what are you talking about?" Of course, he never listens to anything about bees because he's not into bees. Well, if he notices it just looking at him, it's so obvious to him, I think it's a pretty big difference. Mine's certain. I go out and look at other people's hives all the time, and I go home and look at mine, and I go, man, they're just tiny compared to theirs. There's a huge difference in the size of the bee. Now, how does that affect how the bees act and how healthy they are and how they deal with varroa and whatever? That's hard to say, because almost all the research we have on bees is on artificially enlarged bees. Right. So actually, maybe none of the research we have even applies to real bees. We don't know, because we haven't really studied real bees. We've studied artificially enlarged bees. I don't know. Do I think it makes a difference? I think it makes a huge difference. Yeah, that's what I think.
That's so obvious from what you've shown. So, thank you.
Over here.
Yeah, I got a question. Reference your using small cell, because I know you're an advocate of that. Is there anything that you think is the reasoning behind the reduction in the mite population versus the larger cell? Because I've heard people say there's less room in it, but like you said, it's proportionate in the size of the bee.
Well, I got a lot of but it grows to fill the size of the cell. Well, there's a lot of studies out there that would lead some clues as to why it might work. One of them is unfortunately, anything that anybody ever did on bees in Africa or on Africanized bees, everybody just ignores it and says it doesn't apply to our bees. Well, our bees are apis mellifera, and Africanized bees are apis mellifera, so I think it's kind of irrational to assume that none of that applies. But there's a study on male survivorship that was done on Africanized bees, and so far nobody's bothered to try to reproduce it on European bees. But it basically says that the varroa in a smaller cell, this is just taking Africanized bees on large cell and small cell. And because that's kind of an issue in Africa, is that this is the size they normally build and this is the size foundation we're giving them, then what's the difference? They care about it from the point of view of the health of their bees. Should I be giving them this foundation or not? Well, they're looking at varroa, and the males tend to get trapped in the small cell, and they don't tend to get trapped in the large cell. And if they don't mate with those, there's only one male that gets laid right off the bat from one foundress mite. And so that if that male gets trapped, which it appears it does often in a small cell, it gets trapped outside of the cocoon and doesn't manage to mate with the females. So that's one possible mechanism. There's several other possible mechanisms. One of them is if you time it on small cell, from the time the egg's laid until the bee emerges is 19 days, not 21.
Versus, I was going to say, okay, that's a significant difference.
And D. Lusby has the pseudo-drone theory that on the Serrana, basically we know that the mites only infest the drones for the most part. I mean, not only, once in a great while a varroa will infest a worker, but not very often. It's by far it's an exception. It's odd to see a mite in a worker cell in Apis cerana. Well, Apis cerana are smaller, and they almost exclusively infest the drones, and it doesn't seem to hurt the colony when they infest the drones. So everybody will throw this fit about how you should cull out all of your drones because that's where all the varroa reproduce. Well, I got 25% drone comb in all my colonies. I've got lots of drones. I let them raise all the drones they want, and I've got no varroa problems. So I think they're totally wrong. I think they're backwards. I think what you want is lots of drones, and you want them to be reproducing in the drones. Well, her pseudo-drone theory is that a 5.4 is getting close to the size of a drone in an Apis cerana hive.
Right.
And so the Varroa are going to prefer a cell that's about that size. And so we have the problem in Apis mellifera, instead of Apis cerana, that they're infesting the workers. And that's doing damage to the colony because the workers are getting damaged. And we need the workers to not get damaged.
Right, to make it through winter.
So all of those are possible mechanisms, and some of those I've measured, like the amount of time from when the eggs lay to when they emerge. And in theory, in a mathematical model, if you look at what happens, the Varroa goes in the cell, she lays, the first egg she lays is a male. The next, which is a haploid, by the way, which is interesting since that's the way it works with sex determination in bees as well. But the second one she lays then is a female, and then about every 32 to 36 hours she's laying another egg that's another female. Well, if you add that up, that's a lot of eggs from the time that this gets capped on, about day 9, and then she's laying all these eggs. But the only ones that are viable are the ones that manage to make it to maturity and get mated.
Right.
And usually in a worker cell, in Apis mellifera, that's somewhere between 1 and 2 that make it to maturity and get mated at 21 days. Now, you shorten that by 2 days, what happens? Well, you've lost one of those. Now you're down to somewhere between none and a half instead of between 1 and 2. 0, you're down to 0 and 1 instead of 1 to 2. That's a huge difference in reproductive capability. We just chopped it in half. And I think that's probably one of the factors. Another factor that people have noticed is that the first reports I ever got of them chewing out brood were from small cell people. Maybe it's because they were paying more attention, or maybe it's because they chew out brood more. Maybe they're more aware of what's going on in the colony when they're their normal size and they have their normal faculties about them, rather than that they're half again bigger than they should be and they're not as active and observant of what's going on around them. I don't know. All those are possibilities. I don't know of any research that would clench any of those, but there is some research to support almost all of those to some degree or another.
Right. And if I could follow up with one more, and it's not necessarily to divulge, what is your average loss annually? Do you have a number? No.
If I have a mild winter, it could be 1%. If I have a bad winter, it could be 27 below for 2 weeks solid.
Right.
And it could be 40%.
Okay.
Winter has more to do with how many of my bees survive than anything else. Winter is the hard part where I am. It's not. Varroa is not a big issue for me. It's winter that's a big issue for me. It's hard to say what average is when every winter is different. It varies a lot. I've seen winters where our first hard freeze was at the end of September, and it wasn't warm enough for them to fly until May. And I've seen, but that's a pretty unusual winter. Most winters, we get some warm days in the middle where they can fly. But that was a really hard winter, and it really wasn't that cold. It just stayed cold. It's not that we had any 20 below, it was that it just got cold and stayed cold the whole winter. And then I've seen winters where our first hard freeze was at Christmas. Now, that's a very unusual winter. I've only seen that happen once. I've lived in Nebraska for 40 years. I've only seen that once, but so I don't know if there is such a thing as a normal winter in Nebraska. That's my problem.
I guess maybe I should have clarified the question. Did you ever start with like a plastic foundation and keep track of the loss using that, and then switch over and see if there is a great difference, and how much of a difference? Did you ever do any of that research or have those numbers?
I can tell you when I was on large cell comb, I lost 100% of them 100% of the time. And when I was and I lost them to Varroa, because you could look on the bottom board and see tens of thousands of dead Varroa down there.
Right.
When I went to small cell and natural cell, I don't see any of them dying from Varroa. I don't see any Varroa issues.
Okay.
So,
And that's what I'm looking for. In our apprentice books for our state, I don't think we push enough of the natural stuff, and that's kind of when I want to get smarter on that, and then try to push a more natural method versus,
Best I can tell from the statistics, right now about 60% of the beekeepers are not treating their bees. And the statistics on what everybody's reporting on, just very generic categories of they treat or they don't treat. The people who treat are losing 30% of their bees over winter, and the people who treat are losing 30%, the people who don't treat are losing 30%. And 60% of them aren't treating. So what does that mean? I think it means that whatever gains you got from treating, you lost in some other area, and whatever gains you got from not treating, you lost. But all in all, if you look at the sustainability of it, not treating is more sustainable. Not treating eventually will result in more bees that can survive instead of bees that can't survive. So it looks to me like there's two paths here that in the short term have the same result, and in the long term we're going to have dramatically different results. And I think we want the one that in the long term has the better results. But
Right.
does that make sense?
Yeah, I totally agree with you, but I mean, we're still fighting commercial people, bee breeders in California, because if they can't sell us, if they don't have the business because our bees are lasting longer, it's hard to convince them, I think, to get them to change, to fall in line with what we're wanting to do.
Well, that's true. There's nothing in it for them.
Right.
If your bees die every year and you keep buying bees,
Right,
that's
it keeps
a
them in
good
business.
that's a good business model. It's not a good business model for you, but it's a good business model for them. Yeah.
So I have a question about, this is the end of my third year, and my goal so far has just been to keep my bees alive. And so far, so good. I have plastic foundation, and I believe it's the standard foundation from Manlight. So if I want to start switching over to foundationless, what's the pattern? You know, you talked about doing it gradually, like, you know, if I wanted to do it over 2 or 3 years. What's the pattern for where I replace the frames within a box?
Define standard foundation from Manlight.
I thought you said that it was like the 4.9. I think it's the standard versus the premium. I think it's the smaller cell, but I don't know that for sure. But anyway, I want to get rid of it. So if I'm
The PF100s and the PF120s, the whole PF100 series is 4.95 to be exact. 4.94 probably would be more exact. But it's already small cell. I just use it.
So
Keep moving toward natural cell by just introducing foundationals from here on out. Eventually, you know, those break, throw them away, and
So how do I do that?
I don't
If
see
I
a
wanted
problem
to take
with
2 or 3 frames, you know, a year or something, do I do them from the edges or do I do it in the middle of
oh, well, if you view it from the point of view of the honey and pollen you harvest all the time, I mean, honey you harvest normally as a beekeeper, right? So you can pull those out. I'd be trying to feed what I want into the middle of the brood nest to get them to draw it, and then be working everything else to the outside where they're less likely to have brood in it, and then when there's no brood in it, I can pull it out.
Okay.
So anytime I don't have brood in it, anytime I don't have anything in it, that's a great time to pull it out. And early in the spring, I probably have a lot of stuff that doesn't have anything in it I can pull out without any big loss to them because there's no resources in those combs. Granted, they lose the resource of drawing comb, but they're not losing what's in the comb.
Okay, and then one follow-up, if we were, I think we learned that you wanted to like replace the foundation every 2 or 3 years because of the contaminants that were coming in from the pollen and the nectar, where the plants outside are being treated with stuff. So if you're doing...
I didn't say that, but some people say that, yeah.
Okay, so that's not something then that you need to worry about if you're doing foundationless.
I don't know. It's something I don't worry about. Should I worry about it? Maybe I should. I don't know, but I don't. I don't seem to have a lot of control over what people are spraying outside of my hives, but I can control what goes in them, and so I try to control that. Anytime, I've talked to the guys who do most of the research on looking at the foundation and the contaminants in the foundation, the contaminants in the hive. They're doing most of the measurements for the University of Pennsylvania and some of these other places that are doing this research, and they, over and over and over again, it comes down to the majority of what's in that wax is put there by the beekeepers. It's not coming from farmers, it's coming from the beekeepers. So it seems to me that The rest of it probably is minor enough, I don't need to worry about it so much. But I don't know. I mean, anything will build up, but they have moved toward, they moved towards pesticides that break down a lot quicker out there on those crops. The neonics are kind of an iffy thing. They may not break down that fast, plus they permeate the whole plant, but that's another issue I think we ought to be worried about because we are eating those plants. Like some of the pesticides they're spraying now are fairly short-lived. They break down pretty quickly now. The stuff that they're putting in the beehives, the amitraz and the fluvalinate and the coumaphos do not break down very quickly. So again, the stuff that the farmers might get on your bees that are going to come back tends to break down. The stuff that the beekeepers are putting in the hives it doesn't break down. So yeah, I'd worry more about that. That's where I put my focus.
Thank you.
Any more questions?
What's
I think mine is more along the line, I'm a new beekeeper, recapping. I have 5.2 foundation in there right now, so if I was going to start reducing it, I would buy the 4.9 and just start putting it in the brood nest.
You could do that, or you could just do natural comb, either one.
Right.
Either one will get you in that direction. The quickest way is probably the 4.9 Man Lake PF100 series because they almost always draw it the way it's laid out. They don't change the size. Or if you give them wax 4.9, they may rebuild it into whatever. Who knows what they'll build it. And that tends to get them there in a hurry. But some of that's a philosophical thing. You know, if you don't mind plastic, that's fine. If you do mind plastic, I do the natural comb. I don't see anything wrong with the PF100s. I've got lots of them in my hives. I've also got a lot of foundational strains in my hives, and they do well on both of them. So,
Thank you.
sure. I'm going to take a little break.